Okay, part 2, video 3, number 1. The figure below is a circle with the radius of x. Angle, this is theta in the Greek alphabet. It's just gonna denote a missing angle, measures 45 degrees. Well, it's not missing in this case, but it's the angle that we're going to be looking at. Okay, A, find the lengths of A and B of the triangle without using a calculator. The values of A and B will be put then in terms of x. Make sure you show how the values are derived from the information provided. Okay, we talked about this in class, maybe with different variables. But what we have here, if theta is 45 degrees, and this is 90, that would make this also 45 degrees. So what we have here is a 45, 45, 90, and we have to use it to show how we get the relationships of our special right triangle. And we're going to do that through the Pythagorean theorem. So we would know that a squared plus b squared is equal to x squared, because x here is kind of like c, the hypotenuse. And what we're going to do from here is we are going to solve for one of our side lengths. So we know that in a 45, 45, 90, A and B are the same thing. So what I'm going to do at this point is I'm going to take out B, and since A is the exact same thing, I'm going to replace it with another A, because A is equal to B. So when I combine my like terms, I'm going to have 2a squared is equal to x squared. Now I need to work here towards isolating x. So I would take the square root of both sides, and that would give me the square root of 2, and the square root of a squared is a, and that's going to be equal to x. So here we have x, the hypotenuse, is equal to the square root of 2 times a. Please notice that the a is not underneath the radical here. When we took the square root of a squared, we got just a and not the square root of a. So since, I would say something like, since x is equal to the square root of 2 times a, then a would then have to equal what? Well, I'd have to solve this equation now for a. So I have the square root of 2 times a is equal to x. If I solve this for x, I would divide both sides by the square root of 2, which is going to give me a is equal to x divided by the square root of 2. And what we have to do is we have to multiply out the radical, because we cannot have the denominator of a fraction. You can't have a radical in it. So we've covered this in class 2, but we're going to multiply the top and the bottom by the square root of 2, leaving us with the square root of 2 times x over 2, because the square root of 2 times the square root of 2 is 2. And that's weird for people, but if you think like, what's the square root of 4 times the square root of 4? Well, by this rule, we know that it's already 4, but let's just do it. The square root of 4 is 2. The square root of 4 is 2, and 2 times 2 is 4. So that's why the square root of 2 times the square root of 2 was equal to 2. And now we have an expression equal to a, and we also have an expression that is equal to x. Okay, and we could also say here that we have b, because we know that we stated up here that a is equal to b, so b is also equal to the square root of 2 times x over 2. Okay, going down here, b, use the values you found to find the following. Sine of 45 degrees. Well, I know here that the sine of 45 degrees, and I could use either 45 degree angle, is equal to b over opposite, what's opposite 45? B over x. And now I just have to use substitution to state what b and x actually are. Well, b was the square root of 2 times x over 2, and that is going to be over, I'm going to do a side fraction here, over x, which is equal to, or which is just, well, it's just going to be x in this case. Okay. All right. So when I do that division, I need to see what I'm going to get. So if I kind of like to write this out like this. So if I have the square root of 2x over 2, and I'm going to divide that by x, I might think of it like this. And then I have the square root of 2x over 2. And I'm going to use inverse operations here. And I'm going to reciprocal my second fraction. And then I'm going to get the square root of 2x over 2x. And that's going to be equal to the square root of 2 over 2, because my x's will cancel out because x divided by x goes away. So now I have the relationship of sine 45. So cosine 45. Well, cosine is adjacent over hypotenuse. So in this case, that would be, if I'm looking here, remember we're getting all of this in terms of x. So if my hypotenuse is x, and let me redraw this so it's a little bit clearer. It's getting a little jumbled up there. But if I redraw that triangle in green down here, I think it'll be easier to see what's going on. So if I have my triangle and I've determined that it is a 45, 45, 90 triangle, and we stated this as x, we then said that the side lengths were the square root of 2x over 2. And we said that the other one was the square root of 2x over 2 in terms of x now, okay? All right, so what I'm going to do now is find the cosine of 45. Well, the cosine of 45 would again be the adjacent, which is going to be, well, if I was looking, here or here, that would be b over x again. So it's going to be the same as above, okay? So I put like same values as above here. Now tangent 45, that's going to obviously change a little bit, and it's going to be easier because the tangent of 45 is the opposite over adjacent. So that's going to be, this divided by this, and anything divided by itself is equal to 1. So you could just say that, it's the